Give a little bit, give a little bit of my time for you. Give a little bit, give a little bit of your time for me. There's so much that we need to share, so take some time and show you care.
Hey everybody, thanks for tuning in to this week's edition of Video Notes from Mr. Flugum's General Chemistry class. Today we're talking about the periodic table, and I hope you have that periodic table that I gave you in class to help you kind of take notes on this. I want to start out by just talking about Dmitry Mendeleev. That's this guy right here. Okay, he was a Russian scientist, and he kind of gets credit for developing the periodic table. Now there are lots of other scientists working on similar projects at the same time, but he gets the credit because he came up with the periodic law, right? And he developed really the first real good ideas about the periodic table and how it should be arranged. Now he arranged his periodic table by atomic masses. We came up with this periodic table, where instead of using atomic masses to line up and organize the elements, we went with atomic numbers. And that gave us a much clearer pattern and arrangement for the periodic table. Now this is just a little bit of quick review, right? Vertically, the elements are in groups. Horizontally, the elements are in periods. Periods and groups kind of tell you certain things about the elements. Alright, so remember that elements that are in the same group have the same number of valence electrons, right? And that affects the way that atoms interact with each other and bond together. And the way that atoms bond together, it determines a lot of the properties of that element. So that means that elements in the same group have a lot of the same properties. Now if we look at periods, what period tells you about a group of elements is the number of electron levels that they have. So, you know, if you look at these elements here, which are in the fourth period, all right, everything in the fourth period has four energy levels of electrons. And the same would be true in any period that you select. All right, now I already kind of talked about this, but we have several families in the periodic table, and we're going to address those families in particular, give them names that I kind of want you to be familiar with and know, and also give you some of the properties that are associated with that group of elements. Okay, so let's start with this, group 1, all right? That is called the alkali metals. However, hydrogen is not part of that, although hydrogen is in group 1, all right? And these tend to be really soft metals. In fact, you can cut them with a butter knife, and they are highly reactive. So you never find them just sitting around in nature or anything. They're always combined with something. And if we have them, they are stored in underneath oil or some kind of inert substance so that they don't react. Okay, the second group on the periodic table that we're going to talk about is the alkaline earth metals. So these metals are fairly soft, but not as soft as the alkali metals. Okay, and they tend to be silvery or white. All right, they're sort of reactive, but not as reactive as the other ones. Okay, and we call them the earth metals because they're commonly found in rocks and soils in the Earth's crust. All right, so here you see a picture of each of the 6 alkaline earth metals. All right, notice they tend to be silvery. They also tend to be kind of crystal-like in appearance, at least as they are right now. All right, and these tend to be not very strong metals. You don't want to necessarily use them for structural things. All right, they have many other uses. One example of the uses for the alkaline earth metals is in fireworks. They burn with very bright and brilliant colors, and so that's the colors that you see here. Radium, as you can see, tends to be used in the dials of glow-in-the-dark watches and clocks because it has a natural glow to it, because it is a radioactive substance. All right. As you can see, each different alkaline earth metal gives you a different color in fireworks. Okay, moving along, we have the transition metals. That's that large block that's in the middle of the periodic table, groups 3 through 12, right? And these are those metals that you think of when you think of metals, right? They're structural a lot of times. We have many uses for them, okay? And they are very good conductors of electricity, all right? And they're very easily bent, shaped, hammered, and used for all kinds of things. Here's just a few examples of transition metals and the uses we have for them, right? Coins like nickel and copper and zinc as well in coins. Iron that we use in steel, all right? Alloys and things like that we use in rims that are very strong but light, okay? Jewelry, gold, okay? And also metals that we use on the for planes and automobiles and things like that. All right, so here are the other metals on the periodic table, right? They tend to be the poor metals, all right, which means they share a lot of similarities with metals, but they also tend to have some poor qualities of metals, right? They have lower melting points, they're softer, they aren't as structurally strong, okay? And so that's one of the differences here when we talk about the poor metals. One of the things we're going to talk about when we talk about periodic trends is as you move to the left side of the periodic table, things tend to get more metallic in character. And towards the right side, they tend to be more non-metallic, right? So here we are on the right side where we still have metals, but they don't necessarily have all the great characteristics of metals that we are looking for. All right, so here's just some examples of some of those transition metals, all right? Right here, of course, we have aluminum for aluminum cans, right? In the vest there, a lot of times they use lead in X-ray vests, and lead is a very dense metal, so it helps protect your body from the X-rays that are hitting it that are in the areas where you're not getting X-rayed. And then this metal right here has a very low melting point. This is gallium. Okay, so it melts just above room temperature. In fact, some periodic tables list it as a liquid. All right, we've kind of talked about metalloids, right? But I want you to just make note of them on your periodic table there, right? They're along the stair step there. And sometimes it seems like they kind of include some of those poor metals that we talked about, right? The germanium and the antimony and the polonium, all right? Okay, they're very important semiconductors, especially silicon and germanium. You might ask, what are semiconductors used in? They're used in electronics. We make computer chips out of them. And they have a lot of useful characteristics that are very useful in making those electronics because of their semiconductive or only being conductors under certain circumstances. That characteristic of them is very useful. Okay, so nonmetals. Here, there's a few nonmetals that we don't talk specifically about their groups. All right. They just kind of fall into that non-metal category because they're in mixed groups on the periodic table. All right, and just remember that they tend to not conduct electricity, although there's an exception there in carbon. Carbon can kind of be a semiconductor depending on its form. All right, and they tend to be brittle and not very shiny as well, right? Shiny tends to be a characteristic of metals. All right, so the next group we'll talk about is the halogens. So this is group 17 on the periodic table. They are nonmetals. What they share in common is electron structure and the fact that they're fairly reactive for a nonmetal. All right. They also share this in common. They tend to be poisonous. All right. They tend to have a big effect on living things. All right. And we use a lot of them like chlorine or iodine for disinfecting. Right. Making sure things are safe, but we got to make sure that those levels are not too high as well. Right. So this is a picture of 4 of the 5 halogens, right? You got fluorine, which tends to be a gas, but clear. Chlorine, which tends to be a gas, it has a slight yellowish green tint in there, right? Bromine, which is a reddish brown liquid to gas. So it tends to be liquid at room temperature, but it evaporates very easily. And iodine, which tends to be a solid, but has a relatively low melting point. All right, last group on the periodic table we'll talk about is the noble gases, group 18, right? They're all gases and they're all unreactive. They're very inert, okay, which means they hardly react with anything. All right, in fact, it took us a long time to discover these because we discovered elements and by reacting them with things, and these don't react with anything. So it was very difficult for us to discover them. Dmitry Mendeleev had no knowledge of them. One of the characteristics of noble gases is the colors that they produce when they're in a lamp. So there's the colors. You don't necessarily have to write this down, but I thought it would just be interesting. And here are those colors in real life, right? You got your famous good old neon signs, but also different colors for the other different gases. All right, so the lanthanide series, this series right here, should be actually up in the periodic table in period number 6, right there between lanthanum and hafnium. Okay, that was taken out so that we could crunch the periodic table down onto one page of paper. Okay, but they're all very similar elements. In fact, it's very hard to separate them from one another because they are somewhat reactive and they are very similar in their properties. All right, so let's talk about the actinide series, the very bottom row that we have in our periodic table, right? These are taken out. They should be part of period number 7. So they have 7 electron energy levels, right? These tend to be all radioactive isotopes and elements. In fact, uranium is the largest naturally occurring element. Anything above that has been man-made in nuclear reactors and processes, much of which was discovered during the Manhattan Project during World War II when we were developing the atomic bomb. So there it is, folks, the periodic table in all its glory. All right, with all the different groups of elements and the incredible diversity of characteristics and properties that they hold. I want to thank you for tuning in, and I'll see you on Thursday in class. Have a great day. Bye-bye.